Today we're going to look at multiplying monomials. Remember, a monomial, think of it as one term. So in example 1, we are multiplying a monomial y to the 4th times another monomial y to the 2nd. So I always encourage students to think about what it means, and so you shouldn't have to do this every time, but y to the 4th, if you were actually thinking, what does that mean? It's really y times y times y times y 4 times. And then y to the 2nd, if we write down what it means, is really y times y. So when you think of it that way and you break it down into what it actually means, y to the 4th times y to the 2nd is y to the 6th. And hopefully you'll begin to start seeing a pattern. Look at example 2. Example 2 has some coefficients, some numbers in front of your variables. Now, we have talked already about the commutative property. If we do, let's say, 4 times 3 times 2, we're going to get 24. And we could choose to do 2 times 4 times 3. Doesn't matter what order we multiply in. Those numbers can change places, and we're still going to end up with 24. So when you think about it that way, and you think about what does example 2 mean, well, if you were to break this down, this is really 4 times n times n times n times, I'm just going to make that a different color, 5 times n times n. So all we're really doing is multiplying here. So if you wanted to, and if you needed to, you could move the 4 times 5 kind of together, and then the n's, you would have 5 of those. So what is 4 times 5? 20. N times n times n times n times n is n to the 5th. So we would write our final answer 20 n to the 5th. Okay, example 3 is really the same. It just gets a little bit more complicated because of the fractions. And so if I were to reorder this, and you could write it out. This is what it means first, if you needed to. And we're going to talk about a pattern in a minute. So we've got 16/5 times 15/4. And then it looks like I'm going to have x 5 times and y, y 3 times. Okay, so now I can simplify. It looks like since I'm multiplying these fractions, if I want to simplify 15 over 5 to 3 over 1 and 16 over 4 to 4 over 1, that will help me out a little bit. And so I get 12 times x to the 5th times y to the 3rd. And I could write that 12x to the 5th, y to the 3rd. Okay, let's look at this last problem. We really have about 3 problems within example 4. So we have a multiplication problem going on right here. Then notice we have addition. And we have multiplication over here. So let's do our multiplication. Now, I want us to look back at example 1, 2, and 3 and see if you can identify the pattern. Notice we are multiplying by what we call the same base in example 1. So the base is y, and then we have an exponent of 4 and an exponent of 2. So anytime you multiply by the same base, I'm going to write this up here. So when you're multiplying by the same base, I'm hoping that you're noticing the pattern. You're going to keep the base, and that's really important. You always keep the base, and you're adding the exponents. So erase this really quickly. And so that's really your rule today. So notice in example 1, the base is y. So you're really keeping the base of y and you're adding the exponents. 4 plus 2 gives you y to the 6th. So notice that's what we got already. Now, in example 2, when you're multiplying by the n, that n is the same base. The 4 and 5 are just coefficients. So when you're multiplying by the same base, the base being n, you can keep that base of n and add the exponents. And so that's how we were able to get that n to the 5th. And then the same thing applies in example 3. So knowing that, see if you can apply that. And the important piece is that you're always multiplying by the same base if you want to apply that exponent rule. Okay, so 2 times negative 6 is going to be negative 12. Then notice I have a times a to the 4th. If you need to put a little 1 right there, it's understood 1, you can. And so that would give us a to the 5th and b to the 4th. Then I just am going to bring my addition sign down, and I'm going to do the same thing over here. Now, if you need to put the 1 as the coefficient, it's an understood 1, you can do that. So I'm going to get 2, it looks like a to the 5th, and then once again, this is b to the 1st power. So when I multiply those, I'm going to get b to the 4th. Now, from our last section, we were adding like terms. So remember, adding has totally different rules than multiplying. So we can only add things that are common. So you could think of this almost like negative 12 apple banana smoothies plus 2 apple banana smoothies. That a to the 5th, b to the 4th is just an unknown. So you can give it a name so that'll help you. If you lose 12 apple banana smoothies and you gain 2 apple banana smoothies, you're left with 10 apple banana smoothies. Notice the apple banana smoothie part doesn't change. This problem is really not any harder than negative 12x plus 2x. So always go back to a simpler problem. This is a simpler problem. And if you can do negative 12 plus 2x and get negative 10x, notice that x part didn't change. It's just like when we did negative 12 xylophones plus 2 xylophones, would give you negative 10 xylophones. So the main thing is just always go back to what does this mean, and then think of simpler problems to help you. Your addition, collecting like terms, and subtraction, those you have to have like terms, whereas you can multiply anything. And so when you're multiplying by the same base, you're going to keep the base and add those exponents. Okay.